All right. Well, before we get started, I just kind of wanted to, check in with you guys and see how you guys are doing. You guys in the classroom are here, but I also know there's quite a few of you who are at home, hopefully watching this video. And yeah, there are kind of some major, distressing and tragic events, and so we received threats of violence against our campus, and then yesterday I heard that a student had died in the residence halls, and and so I feel the kind of just the weight of a lot of these, the emotional weight of of these events, and I want to make sure you guys are doing okay, and I want to make sure however you process these events, and everybody kind of processes these things differently, right? And some of us, we're like hardly affected, okay? These things happen, and we just go, okay, well that. And that's okay, of course, be sensitive to people around you, but I also want to just say, whatever it is you're feeling or not feeling, that's okay. Some of us, when we feel these things, it often weighs very heavily on us, to the point where it's difficult for us to kind of focus and do schoolwork, and it feels like, school and college, how, in comparison to like kind of these kind of grand questions of life and existence, and it feels, class assignments feel, sometimes trivial, and I would say, yeah, in the grand scope of things, class assignments are trivial in these, in that regard, and it's. I also want to kind of give you space to feel that way as well. I hope. And I want to make sure each of you have people in your life that you can kind of talk to and turn to in tough situations, a friend that you can talk to, family members, maybe a professional counselor, something like that. It's often helpful. And even if you don't want to do any talking, just kind of being in the presence of someone that cares about you can also help and just matter. And so that often requires vulnerability. You have to kind of turn to someone and say, "Can I talk to you about stuff? Do you have the emotional availability to shoulder or carry some of this weight that I'm feeling?" Okay. Other of us, we might be in a place where, we can be that person that people can turn to. Okay, and that, and if that's the case, I want to encourage you to, be available to a friend or somebody who does ask, or who does approach you, or something, or even they might not even want to approach you, and it might just take you initiating, just say, is everything okay? Are you doing okay? And but yeah, it requires sacrifice on your part to have that, because it is emotionally and energetically taxing to have to listen and things like that. But if you have that ability and that bandwidth to do that, I want to encourage you to do that as well. We get through this by supporting others and also turning to others for support, and it requires vulnerability and compassion on each of our parts. So anyway, I don't know what I'm saying, but I hope we can be there to kind of support each other. And and I'm just your teacher, and I'm not professionally equipped for any of this stuff. But if you feel like you need somebody to just talk to and listen, you can talk to me and listen as well. Okay, again, probably. I also draw. I think it's also important to have boundaries, right? So, if somebody is over, coming you a little bit too much, you have to kind of figure out what is an appropriate boundary to draw. And And so, I want to be available to listen, but I'll also let you know that I believe I also have healthy boundaries for myself. And so at some point I might cut you off and say, I don't think I'm the appropriate person to talk to this, about certain stuff. But again, if you just kind of need to voice some things, I'm available as well. I don't know. Okay, well, with that, let's transition awkwardly, and we'll talk about R6 object-oriented stuff. The other thing is, again, I want to be sensitive to the way, however students are processing these events. And so homework 3, the deadline is today, but if you need an extension for homework 3, you can have an extension, okay? And you don't normally ask for documentation to kind of go along with it. So, I don't know what's going on out there. Normally ask for documentation for homework, but for this one, homework 3, I'll just say I get it. Stuff's going on. So if you don't have to submit documentation. You can submit it up to 72 hours late. We won't assess any kind of penalty. If you feel like you need more than 72 hours, come talk to me, and we can figure something out. But we'll do that. Okay. So the original deadline will still be in place, but if you feel like you need an extension, you want an extension, go ahead and take it. Okay. All right. Let's go ahead and take a look at R6 object-oriented programming. And so, on Monday, we had introduced object-oriented programming, and we talked about S3 being R's primary object-oriented system, which is a generic function object-oriented system. And so the generic function, OOP, the methods belong to the functions. So it's like you have a verb, hit, okay? Verb hit, or maybe, verb hit, and, depending on what object I give you, right? So if I say, here's a tennis racket, and I say hit with it, then you'll take the tennis racket and you'll swing like you would swing a tennis racket, okay? Whereas if I give you a baseball bat and I say, hit something with it, the way you're going to hold the bat and the way you're going to swing it is going to be quite different, right? All right, maybe I should say swing. Swing is probably a better word, right? If I give you a baseball bat and I say swing it, the way you're going to swing it is going to look different than if I gave you a tennis racket, okay? So the method of swinging the object depends on the object I give you. That would be kind of a generic function thing where the same word swing takes on different forms depending on the object given. So that would be generic function OOP. In R6, we use encapsulated OOP, which is probably closer to other language object-oriented systems. So if you're familiar with Python or C++, it's going to look a lot closer to R6, encapsulated things. And in this system, the methods belong to the objects themselves. So you'll have an object, and the object will have a list or a set of functions or methods that it is capable of doing. Another thing is that R6 objects are mutable, which means that they are modified in place and they have reference semantics. And we'll talk about what all of that means. To use R6 in R, you've got to load the R6 library. So R6 is not part of base R. Base R has something called reference class objects, which behave similarly to R6, but R6 is a little bit more of an elegant implementation of this encapsulated OOP. So it's kind of the recommended form. So we call library R6, and this will do this. And I'm going to assign homework 4. That'll get posted today. And homework 4 will require you to use R6 as part of your exercise. Okay? All right, so let's talk about classes and methods within an R6 object. And so pretty much the only function that you will use from the R6 library is this function, R6 class. And this is used to define a new object class. And the way we do this is we have to provide two arguments, okay? One is the name of the class, and the other is a list that goes into public, okay? The name of the class is just the name of the class that we're creating. The convention is to use upper camel case. Upper camel case means anytime you have new words, if you're putting multiple words together, you capitalize those new words rather than use underscores. In the public field, which is a list, it's going to be a list of methods and fields. Fields being kind of like values, and methods will be functions. And the methods and fields use snake case, meaning if you got multiple words, you'll use underscores. Now this is not, if you don't follow this convention, it's not going to throw an error, but this is just kind of the convention, and it's good to kind of follow conventions, right? So this is, you take the results of R6 class, you assign that to an object name or variable name with the same name as the class. So here's an example. We're going to define a very, very, very simple R6 class called Accumulator. Okay, and the accumulator has class name Accumulator, capital A, Accumulator, and the public is a list with two items in the list. The first is a field called sum, and it contains the value 0 right now. And the other is add, and this is a method. This is a function, and we'll go over what's happening inside the definition of this function. But basically, we've got two items in our public list, sum field and an add method, okay? And that's it. And so once I've assigned this to Accumulator, and I ask, what is Accumulator? Accumulator is the function that will, it's the object generator, okay? We make calls to Accumulator, and this will create instances of the Accumulator class object, okay? The Accumulator itself, this thing itself, is not an instance of the Accumulator class. This is what we use to generate new instances, right? So it's kind of like each of you can have a bank account, right? But to generate or open a new bank account, you have to kind of go to the bank and talk to a teller or something like that, and they gather all of this personal identification and stuff like that, right? So that process of talking to the teller, and that would be the object generator. That's going to create a new bank account, okay? Whereas each person holds their own separate instance of a bank account. So here, when I call accumulator $new, this will create a new instance of an accumulator, okay? So X is going to be an instance of the accumulator. And so now when I call X, it says this is an accumulator. Whereas accumulator is the object generator, this is an instance of the accumulator. And when you ask for X, the default kind of way it prints out, it says this is an accumulator class object. And inside the public fields, you have the add method, you have the sum field, which is 0, and then there's also a clone method, okay? Now we didn't define clone, okay? We didn't define clone, but clone gets inherited. Clone gets inherited from just the R6 class parent object, okay? So the very kind of the parent instance of R6 class objects all kind of come with certain methods, one of them being clone, others being like, well, I guess that's it, okay? And initialize and things like that. So if we wanted to, we can access any of these public fields by using the $sign notation. So I can say $$ sum, and I'll say, okay, the value stored inside $$ sum is 0. Okay, simple. We can call this method add. And what add will do is it's going to add 1 to the sum. And so I call $$ sum, which originally starts off at 0. I call $$ add, and now $$ sum has been modified to 1. Okay. Now, this is interesting because generally in R, if you wanted to change a value, you have to use an assignment operator, right? So if you had something like j, and you wanted to increment j by 1, you would have to do j assign j plus 1. Okay, normally that's how you'd have to do it if you wanted to increment j by 1. But you don't see $sum assigned $sum plus 1 or anything like that. We just called $add, and this function call modifies $sum. So this is kind of the idea that the objects themselves are mutable, meaning that they are changed in place without having to use the assignment operator, or without having to do j is j plus 1 or something like that. Here I can call $add, and we're going to add 3 to the sum, and now my sum is 4. So what's happening when I call $add? So let's take a look at the definition of the method add inside the accumulator class object. So inside, when we defined our accumulator class object, we created a function called add, our method, and we said the default value is 1. It takes in an argument where the default value is 1. And what does it do? It takes self $sum. Okay? Self is kind of this reference to the object itself. It says within this object itself, is there a field called sum? And there is. So we're going to say within this object, there's a field called sum, which we can access by doing $sum. So we're going to take whatever object name it is, take the access itself, and here this is where we see kind of what we're accustomed to seeing. Self $sum plus x, and assign that back to self $sum. Okay, so this is where that traditional assignment operation modification happens. We do self $sum plus x, assign it back to self $sum, and then we say return self invisibly. Okay, return self invisibly. So invisible is same thing as return, except it does it invisibly. Normally when it returns, it'll kind of output the thing to the screen. Invisible just says you don't need to output anything to the screen. Okay, and one thing is, because I am returning itself invisibly, the result of calling, say, $add is another instance of this object, or is the object itself. The object itself is being returned invisibly. So here I've got $sum, which currently has the value 4, and I call $add 10. Okay, $add 10 modifies sum to 4 plus 10 to 14, and the result of $add 10 is the object x itself. Okay, so you can kind of think of this block here that I've highlighted is x itself, now with a value of 14, and because it's x itself, I've returned itself invisibly, I can also call add 10 again. Okay, I can call add 10 again, and so now we're going to take that value 14, add 10 to it, and now it's 24. This has returned itself. Okay, so this is now x with the value 24, and because it's itself, I can call $sum, and we will get the value stored inside sum, which is the value 24. Right? So we can do this chaining of methods. We can call $add 10, $add 10, $sum, and we can chain these methods. All right? Is that all right? This idea of chaining things? And if you've seen other object-oriented languages like Python, you can chain methods in Python as well with like dot notation. So if you're like dealing with a pandas data frame, you can do like the data frame dot the column name dot location, whatever, and things like that. Don't worry about it if you don't doing Python stuff, no sweat. But this is a nice feature that shows up in a lot of kind of object-oriented systems. You can kind of chain these methods together. For the sake of readability, we often recommend putting each of these chained methods on its own line. It's not required. You don't have to. A lot of times when you write code, the general recommendation is that each line should do one simple thing. Okay? You should do each line should just do one simple change. You don't want to be changing 10 things within one line. You might be able to, okay? But in general, as for the sake of readability, your brains are have a easier time processing just like 1 or 2 small changes at a time. And when you're reading it line by line, it's easier to keep track of. So here, you can achieve the same kind of thing, $add, add 10, sum, and you get kind of the same result, or the same effect of adding 20 to get 44. All right, let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter B. B as in bear. B as in bear is your first view quiz answer. When we create new instances of an object, we use $new, okay? And $new just creates a new instance. We can change the behavior of $new by creating a $initialize method. Initialize, you can put in, create a function that kind of puts in additional arguments or requirements or things like that. So here we're going to create an R6 class named person. Okay, so we're going to create a person, and basically this person class has two fields, a name and an age. And then we're going to define an initialize function. And this initialize function is going to be called when we call $new. So we're still going to create a new instance of a person by doing person $new, okay? But when we do this, we're going to require that a name and an age is provided. Okay, we're going to ask for a name and an age. And we're going to ask, is name character, and is the length of name 1, right? So we want to make sure we're getting a vector of length 1 to be our name. And we're going to throw an error if it's not true. We want to make sure age is numeric and the length of the vector age is 1. And we're going to throw an error if it's not true. And if those things pass, then we will take the name provided in the function and assign it to self$name. So we'll update our public field name. And we'll take the age provided in the function and update self$age. And that's it, okay? And so now, when I call person $new, I can pass it the arguments Hadley, age equals 38. And this throws an error. It says you can't, this is not a numeric thing, okay? So I say, all right, here's Hadley, age equals 38, person $new. We're going to assign this back to Hadley, and this becomes an instance of the person object. And so now I can ask, okay, well, what is Hadley? And it prints out like this, okay? This is the way it prints out. It says this is an instance of a person class object. And inside public, we've got fields age, 38, name, Hadley, and we have these kind of public functions, initialize and clone. Now, this default method, or default way R6 objects are printed, might not be the way you want it to look. So we can also define a print method, okay? The print method will change the way objects get printed when we call for them, or just print out the object. So if I say print Hadley, if I just write the name Hadley, it prints it out. And so now my R6 class definition is getting a little bit longer, okay? We still have the same initialize method, same thing before, but now I'm defining a function print inside the object, okay? And so this is gonna get called, this method will get called anytime I print person or I just type in the person name. Okay, and I don't have to call, the person name $print. Anytime you just ask for it, it'll print this out. Okay, so this is a function, and what is it doing? It's going to use cat to kind of just output stuff to the screen. So the first line will be, we're going to get a person to kind of say person class object, and we indent 2 spaces, and we say name, and we access the field self$name. We access the age using self$age. We also return it self-invisibly, okay? We return the self-invisible. Okay, so now I say, all right, let's create a new instance of the person using this new definition of the person class object. And so now when I ask what is Hadley 2, it prints out using the method we just defined, which says name Hadley, age 38. Okay, so it uses the method that we just defined on this previous page here. Okay, now what we did was we updated, or we changed the definition of the person class object. Okay, we changed this definition by adding a method. When we did that, it doesn't go back and change the definitions of the earlier objects, right? So we created Hadley 2 under the new definition, which has a print method, but the original object Hadley, which we also said was Hadley with age 38, didn't have that print method defined. Okay, so when I created the new method in this person definition, it doesn't go back and update the old thing, right? If you buy a car like a Honda Civic in 2015, and they release a new model the following year, now there's a new model for, every year, the new model of the car. It's not like when they release a new model, suddenly your old car gets upgraded. That would be awesome, but that's not what happens, right? If you want the new model, you have to get it, okay? And we would have to kind of like redefine the thing. So these two objects, they have nothing to do with each other. There's no relationship between Hadley and Hadley 2. They just happen to share the same class name. Hadley is a person class object. Hadley 2 is also a person class object. But those person class objects have not completely different, but they have different definitions and different methods associated with them. And so, as you're working in R, if you're dealing with R6 stuff, having multiple objects that share the same class name with different class definitions and different methods and stuff, that's going to get really confusing. So anytime you change a class definition, delete the old objects of the old class. Okay, and so as you're working, your next homework assignment, you're going to be creating this R6 class object and stuff, and you're going to be updating your definition and things like that. As you're working on it, frequently click the clear objects in the environment. Okay, clear out the objects and have a script that you can kind of run that will run a bunch of these things and define new stuff. You don't want to end up getting confused. You can also set methods and fields and update a class definition after the fact. If you do this again, it doesn't go back and update the old objects created under the old definition. But later on you can say, well, I wish I did this or something. So here I'm going to just define a new R6 class called the Accumulator. There's no public fields provided, okay? And so here we're going to have to kind of define the public fields and public methods. And we use the $set, okay? So R6 class Accumulator, we're going to ask Accumulator $set. Again, this is the object generator. We're going to set a public field sum. It's going to get set to 0. And we're going to set a public method, add, and that's going to be this function definition. Okay. And again, anytime you use set to change the definition of a class, it only applies to objects created under this new definition. Let's look at inheritance. Okay. Inheritance is kind of the idea that you have a child object that inherits from a parent object definition. And so in our case, we have the Accumulator class object, which has a public field sum and a public method add. And let's say we wanted a kind of a verbose version of this Accumulator class object. And so we're going to call this Accumulator chatty. And this is just going to kind of output stuff to the screen as it's doing things. And so notice how we are defining this object. We're going to say R6 class. The name is Accumulator chatty. It is going to inherit from the Accumulator class object. So the Accumulator class object has already been defined. We're going to inherit from that. And within the public fields, we're going to change the definition of the method add. Okay? The definition of the method add, is going to be a function. And what this function will do is it's going to just output something to the screen using cat. It's going to do cat adding x. So whatever function you called is going to call add x. And notice what it does here. It calls super. super $add. So what is going on here? So it says, well, we've inherited from the parent class accumulator. And so I want to access the add method defined in the parent class. The add method in the parent class is, take self $sum, add x, assign it back to self sum, and return itself invisibly. And we're going to say we want to use that. So rather than having to copy and paste the code that was in the parent class, we can just call the method existing in the parent class. So we're going to say super by calling the methods in the parent class super. And we're going to say use the add method in the parent class where the argument x is the value x. Okay, so now we're going to create a new instance of the accumulator chatty class. We'll call this x2. And I'm going to say x2 $add 10, $add 1, give me the sum. And so now it's chatty. It prints out add 10 to the screen, and cats adding 1 to the screen, and it returns 11. And again, because we are using the parent definition of add, which returns itself invisibly, I can chain all the methods together. All right, so this is how inheritance works in the R6 class system. Okay, so I think this slide just has everything that I wrote. Okay, when you call class, if you ask class on an R6 object, it returns a vector of classes that it inherits from. So Hadley inherits from person, and person is also inherits from the R6 class system as well. Hadley 2 inherits from person. Now this person definition is different from the other person definition, but there's no way to know this just by looking at this vector here. We just have to kind of know that, oh yeah, in my code I had defined 2 different classes of person, and you just have to remember that. And again, that kind of stuff is confusing. So, and then whereas the x2 accumulator object is an accumulator chatty object, which inherited from the accumulator object, which is an R6 object. Okay, so that's what we have. You can call class on any of these things, and this is what you'll get back. Let me give you your second view quiz answer. Today's second view quiz answer is D. D as in dog. D as in dog is your second view quiz answer. All right, you can call names on an object, an R6 object, and it will give you basically everything, all the methods and fields that are available. So you can ask for the age, the names, so when you ask for names on Hadley, you got the public fields age and name, and you also have kind of these methods that we've defined, clone and initialize. We actually didn't define these things. These are just these come with every R6 class object. With Hadley 2, which comes from the second definition of person, it has the print method, right? And then the x2 has the sum field, and then the add, and then it also has kind of clone as well. All right, let's. I want to show you a little bit about reference semantics. And so most of R, and this is probably how you're accustomed to working with R, is that R does something called copy on modify. So this first line of code, I'm going to create a vector with the values 1 and 2. And what this does is it creates some object in memory located at some address which stores the values 1 and 2. And I can access this by using the name A. So A points to this location in memory, and it says, oh, the object there has the values 1 and 2. Here, I take A and I assign it to B. So B and A now point to the same object in memory, okay, which contains this thing 1 and 2. This line, where I say take the first object in B and add 10 to it, okay, and assign it back to B1, R recognizes this and it says, oh, we are trying to modify the value in B, and when it sees this, it does copy on modify. So it's going to take that object 1, 2, which A points to, and it's going to say, I need to make a copy of this. It creates a copy with 1, 2. And then it says, I'm going to add 10 to this first value, which now is 11, and then we say, and then we're going to have B point to this thing. So B points to this other object, which has 11, 2, and A points to the first object that we had created, which is 1, 2. So when we ask for A, it's 1, 2, and B is 11, 2. And this is kind of how we're accustomed to operating with R. We don't necessarily think about all of these things, but when you do like B1 plus 10, we know it's going to modify B, and we don't expect it to modify A. So A remains 1, 2, B is now 11, 2. With R6 has reference semantics, meaning the objects themselves get modified. We're not creating copies. So here I'm going to create a new instance of the accumulator class object, and we're going to call it X. So here's this object in memory, X. And then we take the name Y, and it also points to the same object. So X is pointing to this object, Y is pointing to the same object. We call Y $10. So we say, take this object, run the method, add 10 to it. So now this object contains the value 10 in sum, okay? And so notice what happens because X is pointing to the same object, if I ask, even though I called add 10 to Y, when I ask what is X sum, well, X is pointing to the same object, so the sum here is 10. What is Y $sum? The sum for Y is also 10. They're pointing to the same object in memory. It's like having, this is basically giving multiple names for the same object, right? So you might have a friend Thomas, and somebody calls this person Thomas, somebody else calls this person Tom, maybe someone calls him Mr. Jefferson or whatever. They're all different names for the same person, and so if this person, changes some attribute, it affects all of them, because these are just basically different names for the same thing. If you don't want this behavior where you say, you know what, when I said X and Y, did this, I don't actually want Y to point to the same exact object as X. I want Y to be a copy of this. You have to use the clone method. You use the clone method. So here, X is going to be a new instance of the accumulator class object, and Y is going to be a copy or a clone of X. And so we create X, accumulator class object, and then we clone it. So whatever X, so right now the value inside X for sum is 0. We're going to create a clone, and so this value will now also be 0. And these are now two separate objects. This is called Y, this one's called X. We can say add 10 to Y, all right? So after we've added 10 to Y, we ask, what is the sum inside X? Well, the first object was never touched, so sum inside X is 0. What's the sum inside Y? The sum inside Y is 10. So if you want to have this kind of thing where Y is a different thing from X, you have to call clone. Okay. Otherwise, these two things are pointing to the same object in memory. And that's what we mean by reference semantics. Okay. Now, reference semantics can end up being tricky. Okay. So in regular base R, if you see a function like this, or lines of code like this, X, the value of X gets modified or assigned when we create it here. Okay, we create a list and we assign it to X. We create a list and we assign it to Y, and then we call a function. This function, we don't know what it does, but this function takes in X and Y as arguments, and then it returns some value, and it assigns that value that it returns to object Z. Okay, when we see something like this, because this is just base R objects, we know that if I ask for X after I run this, it's still going to be list A equals 1. And if I ask for Y after I run this, it's still going to be list B equals 2. We know that this function call is not going to modify X or Y, because the only way functions interact with the objects in the global environment is through the returned object, and that returned object is now currently assigned to Z. So we know that a change to Z the only thing that changed with this function call is Z. Nothing else has changed. Okay? this looks identical. However, these are fictional. Again, I've just made up some imaginary object, and this has a capital L list. Okay, so meaning this is an R6 class. Now, inside this function, there could be lines of code that modify X and modify Y, right? So if inside X, if X is like an accumulator object, inside this function F, we could make a call to say like $add or something. And that would actually modify the values inside X, okay? And we don't know what this function is going to do. Okay, we know that the function will modify Z because we're taking the output and assigning it to Z. But we don't know if inside this function, if there are lines of code that will also modify X or modify Y. Okay, we know that X and Y come in as arguments, but within that code, there could be lines that modify X and modify Y. And when you're trying to, let's say you run some function or you write a script and X ends up with different values than you expect. You have to kind of go back and read through your code and you have to try to figure out where is X being modified. Okay, and now it's a lot more complicated because back here we knew X was only being modified when we see this assignment operator. Now X could be modified wherever there's an assignment operator. It could be modified inside a function call where X is being used as an argument. And we don't know unless we remember exactly what we wrote inside the function definition of F. And there could be a whole bunch of different function definitions, right? There could be function definition F and function definition G and function definition J. And any of those things could be modifying X. And you have to now kind of keep track of all of these things in your head to remember which ones modify X and which ones don't and things like that. So this gets painful. And so a tip, and again, these are tips. This is not going to cause an error if you don't follow these rules, but to just kind of help your life so you don't, you can kind of keep track of things. We say if you're going to use reference class objects or R6 objects, your functions should only do one of these two things, but never both, okay? Either it returns a value, but doesn't modify any of the inputs. Okay, so the values come in and it returns a value, doesn't modify anything. Or it modifies the inputs, but does not return a value. Okay, and if you kind of follow these principles, it'll be easier to read and understand what your code is doing. So, for example, here's a function. I'm defining a new function. This one is going to take in inputs, modify the inputs, but it doesn't return a value. So here we create a new function called, or new instance of the accumulator X. This function is going to be called add 5 to sum. It takes in an accumulator object and it's going to call accumulator $add 5. So this will modify whatever object comes in. It doesn't return anything. So I call add 5 to sum on object X, and now X sum is 5. Okay? It modifies X in place. We don't see any kind of assignment operation here. We don't see this assignment operator. So when we look at this line of code, we can say, okay, well, this is modifying X in place. Whereas over here, in this instance, we are not modifying the input. The input accumulator comes in. We're going to take the sum field, multiply it by 10, and return that object, return that value. So we do sum times 10 on X. We're going to assign it to Y. Y takes on the value 50. Okay. Here we see the assignment operator. So this will be an indicator to us that we are not modifying the input object X. And indeed, when I ask what is the input object X, $sum is still 5. Okay. And so if you follow these kind of principles, that will help you keep track of things. Otherwise, you're going to read some code like this. So if we follow these principles, then we say, okay, well, because it's being assigned to Z, I don't have to worry about X being modified or Y being modified. Okay. But if you don't follow these principles, then you might also be modifying X somewhere inside this code, and that could end up causing headaches. Okay. I want to talk about public, private, and active fields. These, but I'm going to run out of time. So let me give you your last view quiz answer for today. today's last view quiz answer is A. A as in apple. A as in apple. All right, and I'll also just say the stuff on private and active fields, this stuff will not be on the midterm exam. So the midterm exam we're still planning for 1 week from today, February 9th. So that's still going to be planned. And on Friday, I will go over what you can expect to see on that midterm exam. Okay. Oh, I sent out like a survey, and a lot of you responded. But basically, I just need to know like if you're available to take it in the evening or whatnot. And I'm going to try to split up the number of students so that the classroom density is lower than completely full. Okay. And so we'll see. But please respond to that survey. Okay. Also, I'm going to post a homework assignment. You don't need to use private or active fields in your homework assignment. Okay. So the difference between public and private. So in public fields, in an R6 class, you can access the values directly, and you can modify the values directly. When you have private fields, those values can only be accessed from inside the object. Only the object has access to it. They can't be accessed from the outside. So let me just kind of show you an example here. Here is a person definition, and we're using public fields for name and age. And so under this definition, I can just say, hey, Hadley to $age. $age is the number 38. Okay, fine. But it's also publicly available, so I can just do Hadley to $age, and let's assign the value 25 there. Okay, and now Hadley to $age is 25. Okay, so we can access it, we can find out the value inside, and we can also just modify it directly from the outside. And maybe we don't want this. Okay, maybe we don't want somebody to be able to just change the values inside this object. So what can we do? Well, we can create a private list. Okay, we can create a list called private, and we're going to put age and name in there. Okay, and when we initialize create a new instance, we'll take the name and age and assign it to private $name and private $age. And when we print it, we can access, because print is being called from inside the object. Because of that, we can call private $name, private $age, and we can access those values. Okay, so under this, we're going to create a new a person with a private definition. And so if I say Hadley $age, we get back null. Okay, this is not accessible from the outside. The age is now a private field. We can't access it from the outside. This also prevents us from modifying it. So if I say Hadley $age, assign 25 to there, it's going to give me an error. It says you can't do that. Okay, but those values do exist. It's under private $age, and we can access them when we call print. We can get access to private name and private age, and we can see Hadley and 38. And one thing about private doesn't mean secret. It's not like encrypted or anything. It's not like a secure way to store secret information. It just means we can't access and modify it directly from the outside. We can't do stuff like this. Okay, so and then there's something else called active fields, and I'm going to run out of time in like 1 minute here. But active fields look like public fields. Okay, you can call $sign and the name of the active field, and it looks like a public field that you can just access directly. But this active field is actually generated by a function. It's actually generated by a function. So here's like a silly version or silly example where we're going to say, give me a value for random. Okay, we're going to have a rando class object, and one of the fields will be random, and the value for random is generated by a function. Okay, and so if I call x $random, notice this looks like a field. We're not calling, it's not a method with parentheses. It looks like a field, like a thing, and it comes back with a number. X $random comes back with a different number. X $random comes back with a different number. Okay. This is it looks like a field, but it's generated by a function. the active field is useful, and especially if you use them in conjunction with private fields. Because sometimes, so back here when it was private fields, I couldn't even ask, what is the age? I couldn't ask what's the age. It comes back and says, no, you don't have access for that. You know, maybe we don't want this behavior where we want to say, if you try to assign 25 to age, we don't want that allowed, right? Because with public fields, we could access the value, but we could also modify the value. Maybe we want this, where we can access the value, but we don't want to allow people to modify. We can do something like that with an active field. Okay, so inside the active field, all right, so you're going to have to just read kind of the definition of what's happening here. Okay, but what we can do with an active field is we can access the value age. Okay, we can access the value age, and it comes back with 38. This number 38 is being generated by a function. Okay, and if I try to assign 20 to age, it comes back and gives me an error. Okay, and this can be kind of controlled using active fields. And what's happening inside the definition, okay, is that when you try to assign something here, the function, the active function gets a value, and it's going to be not missing. There's a value here. Over here, when we're just asking for age, no value is being provided, so the value is going to come back missing. So inside the definition for age, okay, we say it comes with a function of value. If it's missing, okay, which just means we're accessing it, we're going to say give you the value of age inside private. Okay, private $.age. Okay, whereas if it's not missing, meaning someone's trying to assign it, we're going to give back this error that says age is read only. Okay, and that's what's happening here. When we call $age and there's no kind of assignment operator, that value is missing, so we're just going to retrieve that value. And if it's in this case age, the value is not missing, we're going to come back and give you an error. And there's other examples that you can kind of read through to kind of make sure you understand. But we'll go ahead and end here for today. Sorry for going a couple minutes over, but we'll end here for today. And we'll see you guys on Friday. I'm happy to see you guys. I hope you guys are doing well. Have a great rest of your day, and we'll see you guys later.